My dear students, I welcome all of you for today's session on system modeling and simulation. In this session, let me have a discussion about the model of a system. What actually model of a system? Okay, then also we'll have a discussion about the types of models. Got it? So then we'll just have a look at, okay, at the end of the session, I'm just going to introduce you what actually discrete event system simulation. Got it? Clear? So the main objective of this subject will be introduced at the end of this session. Clear? So before proceeding with this session, let me recapture the contents, the topics, okay, we have discussed in the previous sessions. So at the start, I just given you an introduction to simulation. Remember, simulation is always an imitation. Then I had a discussion about model, right? A brief introduction to model. That's nothing but representation of a system. And I have given an example, right? So when you are going to construct an house, okay, on the paper, white paper, we will have a plan how the house will be constructed. So that is nothing but a model. That is nothing but representation of the house that is going to be constructed. Clear? So in general, model is nothing but representation of a system. So then I have just said about the computer-based simulation and mathematical based simulation, right? So then we have seen in what situations simulation will be appropriate, in what situations simulations will not be appropriate. I mean, when we should prefer simulation and when we should not prefer simulation. Okay. So also we had a discussion about advantages and disadvantages of simulation. I repeat, although I stated few things as disadvantages of simulation, okay, they are not the disadvantages at present days. I said right, because for each disadvantage, I said how those disadvantage has been overcome through the advancement in simulation technologies. For example, say, I said one of the disadvantage is simulation results are difficult to interpret. Clear? Simulation results are difficult to interpret. But what I said, how that disadvantages overcome, because in simulation package itself will come up with output analysis tools. So the simulation package itself is going to analyze, itself is going to interpret simulation result. Yeah. So though I stated a few things as disadvantage, they are not disadvantage at this days because of advancement in simulation technologies. So also we had a discussion about system and systems environment. Got it? So you're clear with system, right? I've taken an example of a college system, banking system. Clear? So in system is made up of components, and those okay, and system is nothing but what I said. System is nothing but collection of objects. Got it? Collection of objects or entities that work together to accomplish some goal. Is it? So for example, and there are some components of system, what I said, entity. You remember entity, right? It's an object of international system. For example, customer of a bank is an entity. Faculty, students of college or entities. Then I told about attribute. Attribute is nothing but property of an entity. For example, account balance is nothing but an attribute for a customer account, for a customer of a bank. Clear? So then I said about activity. Activity, you remember, is a time duration of specified land. I mean, for example, let me consider an example for an activity. The moment your deposit transaction initiates to the moment your deposit transaction ends, it's an activity, because for transaction there's a time duration. That time duration I'll call an activity. Got it? So then I discussed about an event. Event, what I said, some occurrence that causes state of the system to get changed. Clear? State of the system will get changed. For example, in banking system, state of the system may be, what state of the system may be? Number of customers in a bank. Okay. Then status of the server, status of the teller, whether is busy serving the customer or idle serving the customer. Got it? Clear? So then we have seen something known as types of exogenous, endogenous. Clear? Clear. This is about, then I had a discussion about environment. I said environment means some changes happens outside the system, and that changes impact the performance of the system. Got it? Changes happening occurring outside the system we call occurs in the system environment. Got it? So these are the things we had discussion till today. And now in this session, let me proceed to what is the model of a system. Okay. So coming to agenda of this session. In this session, first I'll tell you what actually model of a system. Okay, let me introduce with some ideas. Okay, then I will tell you what actually model. Then we'll see types of models. Okay. Then again, how the simulation model will be characterized in detail. Okay, we'll have a look at that. Finally, I'll introduce you to what actually discrete event simulation means. Clear? So, see here, I want my students to study one particular real system. Okay, I want my students to work, okay, to experiment with some real system. Okay, to understand a relationship between the components of a system. Okay, and to predict, okay, to analyze how the system will operate under new policy. Okay, got it? I want my students to experiment with some system. I want my students to study some system. Okay, they need to analyze, they need to predict how the system components will interact. Okay, so I won't allow them to work with the real system. Got it? If I make them to work with the real system, there might be some impact, negative impact on the system. So to study the system, it is to study, but I want my students to study the system is they should experiment with the system. Clear? But but I won't allow them to study or experiment with real system, because that may result in negative impact. So what I will do, I will ask some representation of the real system. Okay, seems exactly, imitates exactly as real system, but not the real one. Okay, allow them to work with that representation. Okay, and that's representation of a real system is nothing but a model. Clear? Got it? So clear? So as it becomes impractical for students to experiment with real system, as it becomes impractical for students to experiment with real system, they will work with the representation of a real system that we call a model. Clear? For example, let me say why I won't allow in general, okay, not students, in general, why we won't experiment with the real system. For example, I'll give you a better example why we are not going to experiment, why we are not going to predict the changes in the real system. For example, let me say, in a bank, okay, suppose if I reduce the number of tellers, assume tellers here in the case, assume the one part, the designated employee of a bank, okay, who is going to offer service you. Got it? So now, what happens? Suppose I want see what may be the impact if I reduce the number of tellers. So if I directly experiment, okay, I mean directly if I reduce the number of tellers in a bank, the length of the customer might, I mean queue of the customer might get increased. So what happens? Customers will get irritated, okay, because of their busy schedule time. And now since the number of tellers got reduced, customers need to wait for a long time in a queue. So customers, what they will do, they may change the account from that particular bank. They may shift their account from that particular branch to some other branch. So what happens in this real experiment? I mean, real experiment means at the real time, I reduced the number of employees in a bank. I mean, designated person, designated employee serving the customer, I reduced in real time. When I reduced in real time, the number of customers in the queue being waiting for service keeps on increasing. So what happens? Some customers, because of frustration, they will shift the account from that particular bank to some other bank. Got it? So what I said, we should never experiment with the real system. We should experiment with its representation. There we should see the impact on the performance of the system. If it is positive, let me apply that changes. Let me experiment then with the real system. Clear? Clear with this? So now, what is model? Model is defined as a representation of a system. I tell you, model is listen. What is model? Model is defined as a representation of a system for the purpose of studying the systems. I repeat, model is defined as a representation of a system for the purpose of studying the systems. Got it? Why I need to represent a system? Because I want to experiment, I want to study about the system. And that representation is nothing but model. Okay. And see, I need not, while modeling a system, okay, I'm modeling a system, I'm studying the system with some particular objective. Because when I consider a system, okay, there may be a lot of objectives with respect to that system. Lot of objectives with respect to that system. But when I consider a part of those objectives, okay, I may need to consider only few aspects of the system. See, when I need to study with some particular objective, got it? I need to consider only few aspects of the system, okay, and only those few aspects I need to model. I need not have to model entire objects within a system. I need to consider those aspects of a system, okay, that is required for the objective that is being under investigation. Clear with this? So in bank, in just example, what I said, some customer waiting for service such as deposit or withdraw, and only with respect to those tellers, I need to study the system. But there are some other objectives of the bank also. That is like providing the loan, got it? Recovery of loan, those things. Okay. So when I'm not concerned with the loan, I need not have to consider the aspects related to loan department. Clear? I mean, I need to consider only those aspects that is concerned with my objective. Clear with this? Okay. So next, okay, coming to types of models. First, let me tell you system. Okay, now this is now let me see types of models. Okay, so one has to listen. There's a problem. Now I want my student to work with the system, to study about the system, to experiment with the system. Clear? Of course, they can directly experiment with the system, but that is not preferred. Okay. So, but if the direct experimentation is easier, let them work with the system, provided the direct experiment with actual system should not have negative impact on the performance. Got it? So we'll exclude this experiment with actual system. Now, experimenting with the model of actual system. Okay. Now I said I need to develop model. Now I need to develop a model for a system, and I want students to work with, to study about the system through that model. Got it? So model, when I say, are of two types: mathematical or physical. Models can be classified as mathematical or physical. Now, what is actually physical model? Sometimes physical model seems like physical existence. Some you might have seen in some huge complex and all, they will have the model of the entire building, entire complex. Got it? So you can fail. That may be a physical model. Okay, but in this entire now in this entire subject, okay, we are going to study about mathematical model. Got it? So mathematical model, I mean, it is a usually uses symbolic notation and mathematical equations. Mathematical model usually uses symbolic notations, okay, and mathematical equations to represent a system. I mean, you might have seen some IEEE papers, right? There are some mathematical expressions will be there, and to analyze that mathematical, you have seen IEEE papers, so there are some mathematical representations. Got it? And those mathematical representations, mathematical expressions, sorry, those mathematical expressions, what you have seen in IEEE paper, they are nothing but represent some model, some system. See, I repeat, mathematical model uses symbolic notations and mathematical equations to represent a system. For example, you have seen your IEEE papers, there are some mathematical expressions. Okay, you feel complicated. Those mathematical expressions are nothing but representation of a system. Okay, and the simulation model is just a case. Simulation model is nothing but a mathematical model. Okay, simulation model, what we are going to study in this subject, is nothing but a mathematical model. Clear? So now, again, more a similar. Okay, I'll tell you about analytical solution and simulation later. Okay, in the while after giving characterize our classification of simulation model. Okay, so again, simulation models further classified as deterministic or stochastic. Okay, simulation models again classified as deterministic or stochastic, static or dynamic, continuous or discrete. Okay, simulation models further classified as deterministic or stochastic, static or dynamic, continuous or discrete. Now let me tell you what actually static means. See, a static means I want to know the status of this system. I want to know status of any system. Say for example, a bank. Okay, or example, a classroom. Okay, I mean number of students in the classroom, a sharp 9. Might be few students might not have arrived to the college. Got it? What may be the number of students in the classroom at 10:30? This is nothing but status. When static means at a particular specified time, what is the status of the system I am going to study? Got it? For example, in a bank, the number of customers inside the bank at 11:30 and number of busy tellers in the bank at 11:30. Got it? This we are studying a status of the system at a particular point of time we call static. So dynamic means for a duration of time. I want to model a system for a time duration starting from 11 through 11:30. Got it? Clear with this? So I repeat, static simulation model, also called Monte Carlo simulation, got it, represents a system at a particular point of time. Now, let me give you, I've given you an example for static simulation, right? Let me give you an example for a dynamic simulation means I need to consider the status of the system that varies from, if I say number of customers and number of busy tellers in a bank keeps varying from 11 through 11:30. Okay, I need to simulate for those duration. Okay, I need to simulate for those duration 11 through 11:30. Then I need to see the output measures, such as throughout this half an hour session, how many customers were there in the system on an average, and how many time duration the tellers were busy on an average. Got it? Throughout the time throughout this half an hour session, okay, from 11 through 11:30, how many customers were there in the system on an average, and how many busy tellers were there on how many time duration the tellers were busy from 11 through 11:30 on an average. So this is dynamic. Now let me come to deterministic or stochastic. Okay, so deterministic means, let me tell you one example, then I'll tell you what is deterministic. So now let me say a child or you, okay, or any of your family member got sick. Got it? Health is upset. So what you will do first thing? So patients in general, let me call patients, and not a patient, as some customers in general I can call as a patient. They need to consult a doctor for some treatment. So what do you do? For example, if say I said for a dentist consultation, okay, clear, or for a pediatrician consultation, okay. So what you will do usually, first you will contact, you will dial the contact number of that particular clinic. Got it? Will make call to a clinic, then you will you will get an appointment. Okay, you will be told to arrive the clinic at sharp so and so time. So I mean to say, in this system, okay, in this treatment, okay, what first the patient need to call the clinic, need to get an appointment. Your appointment will be scheduled, and at that particular time you need to arrive to the clinic, take a treatment, take a prescription, and then you exit from the clinic. Means such a system we call deterministic. Deterministic means prior, earlier itself we will be knowing when the input is going to arrive to the system. Got it? So deterministic system are those for which we know when the input is going to arrive to the system. Prior information will be there when input is going to arrive. So for each input, okay, because while each input we know what will be the service time. Okay, what may be the service time, and we know when you are going to depart. Because suppose you are coming for just for pediatrician clinic, and as just you said earlier, as for checking for some fever, whatever it be. So doctor will know on an average what may be the time is going to take. So it's probably we'll know when you're going to depart from the system. That is output. Yeah. So deterministic, okay, models have a known set of inputs. Known set of inputs. Why I say known set of inputs? Because you have taken appointment from the clinic earlier itself, right? And you're going to arrive to the clinic, going to the clinic at a specified appointment time itself. Because so it means known set of inputs. Deterministic system has known set of inputs, which will result in a unique set of outputs. So what about the stochastic? So stochastic systems are those. Okay, stochastic systems are those where we don't know when input may arrive to the system. Since we don't know when input may arrive to the system, we can't, and what type of input may arrive to the system, we are not knowing initially. Got it? Means input may arrive at random fashion. I mean, stochastic system or those system, okay, in which we are not knowing one input may arrive to the system. For example, let me tell you, bank opens at 9:30. Whether the bank manager or the bank employees will be knowing when the customers will be arrive, they won't be knowing when customers are going to arrive and for what type of services customers are going to arrive. None of the bank manager, none of the bank employees will be knowing. So, but bank will open at 9:30. Assume customer may arrive and wait in a queue before 9:30, or maybe after 9:30, after 10, 10:30, 11. It's unknown. So stochastic system are those systems where the input arrival will be not knowing. Means inputs are random. Means stochastic system are random inputs. Got it? Stochastic systems are those which have random inputs. And since we don't know when, since earlier itself we are not knowing when customers are arriving, for what type of customers, for what type of service customers are arriving, it's unknown. So when the customer arrives, based on their type of service, okay, they may depart at any time. So the output from the system is also random. Got it? Output from the system is also random. I mean, for what type of service request they are coming, whether they are coming for transaction, whether they are coming for withdraw, whether they are coming for deposit transaction, whether they are coming for withdrawal transaction, whether they are coming for mini statement request, whether they are coming for a loan inquiry, it's unknown earlier. So stochastic system is those systems in which customers arrive at random time, that we call random inputs. And since we don't know for what type of service they have come, their transaction activity time also varies, right? Their activity time also varies. So we call random outputs. So activity time is going to vary. So the output from the system is also unknown. So we call stochastic system is those systems which have random inputs and random outputs. Deterministic means, remember, one input is coming to the system, it's known earlier. Hence, we know output. Because I said, right, when you want to enter a clinic, when you want to consult a doctor, first you are going to take call a clinic and you'll take an appointment time, and you'll be said when to reach. Got it? So now means you're going to reach at the scheduled time. So one input is going to arrive at the clinic is known earlier. So deterministic means no random inputs and hence no random outputs. Whereas stochastic means random inputs and random outputs. Static or dynamic, I said, right? Static means at particular point of time. What is the number of customers in a bank? How many tellers are busy? Dynamic means what is the status of the bank from 11 through 11:30? From 11 to 11:30. In 11, among 11 to 11:30, on an average, what is the waiting time of each customer? Got it? What was the average queue line? Okay. So now there are again two types of system: continuous or discrete. So I think I said about these two systems in last session, right? So discrete system is the state of the system vary over a discrete set of points in time. Clear? Discrete system is the state of the system varies over a discrete point of time. So modeling a discrete system we call discrete model. Got it? Continuous system means the state of the system keeps varying over a time. I said like dam, water flow from a dam, right? That's a continuous system. So discrete means here I given an example. So queuing means you want to perform some ATM transaction. You will reach at the ATM counter. Okay. So at the moment you reach, any other guy may also reach. But before you and other guy reach and the next arrival, there may be a time gap. So such a system we call discrete system because there's a time gap between occurrences of events. Got it? Occurrences of events. Clear? So now this is about model. So I've given you an introduction to model, right? I said two types: mathematical, physical. And the simulation model, what you're going to study is nothing but a mathematical model. Again, a simulation model is characterized as deterministic or stochastic, static or dynamic, continuous or discrete. Now, let me give you an introduction to the main objective of this subject, that is discrete event system simulation. Got it? So discrete event system simulation. So I think you know what is system, right? So what is system, event. Event means an occurrence that causes state of the system to change. If the state of the system changes, or if event occurs, see, listen, now I need to tell you about discrete event system simulation. I repeat, discrete event system simulation. System, simulation, imitation of the system. What is event? An occurrence that causes state of the system to change. An event is an occurrence. An event is an occurrence. Listen, an event is an occurrence of something that causes state of the system to change. And these events occur at discrete set of points. I mean, one event occurs now and causes the state of the system to change. After a second, if another event occurs, even that causes the state of the system to change. Next, after a minute an event may occur, state of the system may change. Got it? So if an event occurs at discrete points, so the state of the system changes over discrete points of time, then such a system I call discrete event system. And the model I'm using to study, model I'm using to study, to experiment. Okay, model I'm using, model I'm representing to study or experiment with discrete event systems, we call discrete event simulation model. Clear? So what actually discrete event simulation model is? The modeling of a system. See, listen, discrete event system simulation model is a modeling or representation of systems in which state variables change only at discrete set of points in time. I think clear with the definition, right? Discrete event system simulation model is the modeling of systems. Modeling of systems or representation of systems, those systems in which state variables change only at discrete set of points in time. Clear? And stochastic, I said, because when I want to say I'm simulating a system means I should not take a simple example. Okay, I may need to consider very lengthier example. I need to generate long sequence of inputs, which results in long sequence of outputs. And while simulation, okay, how we need to simulation? Simulation should be like realistic. I means because I said I don't have one because now the question you assume that I need to simulate a bank system. So I said none of the manager employees knows when customers are going to arrive. Means randomly customers may arrive to a bank. So the discrete event system simulation, the inputs are stochastic, means random inputs. Got it? And here we are, it's a dynamic. Dynamic means we are simulating a bank system maybe for an entire day, not for a particular point of time. Okay, starting from 9:30 to 5, we may simulate. Clear? So bank example is the better example for discrete event simulation model. Clear? So I think now you're clear with this basic concepts till today what we have discussed, starting from what is simulation, what is model, appropriate, and when simulation is not appropriate, advantages, disadvantages. Next, we had a discussion of system and its environment. And in this class, we had a discussion about models. Okay, go through each of this topic, okay, until you get familiar. So with this, let me wind up my session. Thank you.